So, a sub 1, d, this is an arithmetic sequence. We know the first term is 13. We know the common difference is 5. Let's find the third term. Not too shabby. First term, second term, third term. First term is 13. Common difference is 5, so it means we're adding 5 each time. So add 5, you get 18. Add 5, you get 23. So a sub 3 is 23. Now, let's pretend we have to find something further off. It might be helpful to write your nth term equation. And so what we've been finding helpful is if you can use the a sub 0 plus whatever d is times n. A sub 0, if you continue the pattern backwards, subtract 5, you get 8 plus 5 times n. And so you could use that to find your third term. 8 plus 5 times 3. 5 times 3 is 15, plus 8 is 23. And so you could do that as well. You don't need to in this case because you're so close to that other term. Let's try another arithmetic. So, to get from the 12th term, 13, to the 18th term, 43, I have to add something multiples of times. So 13 plus some d, whatever it may be. And if I do it 6 times whatever d is. And I say 6 because 18 minus 12 is the number of differences we have. And that's going to be equal to 43. So if you think through, okay, the total change is 43 minus 13, which is 30. So the common difference must be 5. So then, to get to the 62nd term, why not start at the 18th term? 43 plus 62 minus 18. Just to be sure, 44. So 44 times 5. If I add 5 44 times to 43, I will get to the 62nd term. So 43 times 44 times 5 is 9,460. So again, we used the total difference, number of differences, to find d, 5. And then said, okay, well, there's 44 more differences, 44 times 5, to get to the 62nd term. And that's where 9,460 came from. On to some geometric. So we know our third term, 100. And we're going to multiply by r because we're now geometric. We're going to multiply by r 4 times, and that's coming from 7 minus 3. There are 4 ratios being multiplied to get to whatever the 7th term is, g sub 7. And so I'm going to multiply by 1/4 4 times. So 100 times 25 over 64. This is the 7th term. So we had the r. In the next one, we're not going to be given the r, and so it's kind of, we're going to approach it very similar to how we did the arithmetic. So if we have our 12th term, 13, and we have our 18th term, we're going to multiply by some r to get to the 9,477. There are 18 minus 12 multiplied r's. And so that's 6. So r to the 6th is 9477 over 13. 729. So how do we get rid of r to the 6th power? Well, if it's squared, we would take the square root. If it's the 6th power, we're going to take the 1/6 power, which is the 6th root. But I'm taking the 1/6 power because it's easier to type into the calculator. So you've got 3. 729 to the 1/6. Make sure you put the 1/6 in the parentheses. And so you get 3. That's the r value. So then if we want to find the 62nd term, it's going to be pretty teeny tiny. But we start with, say, it's going to be huge, is what I meant to say. 9477 is our 18th term. And 18 to 62 is going to be, again, 62 minus 18, 44. So I'm going to multiply by r 44 times to get something. And so our r is 3. So 9477 times 3 to the 44th. I get 9.3327 times 10 to the 24th. A rather large, and I mean extremely large number. We're moving that decimal 24 times. All right, let's move on and talk about some series. We're going to be adding numbers together. And so 2 different things we can have. Arithmetic, if you add up a bunch of numbers that have a common difference, the sum is the first term and the last term added together. And then the number of pairs. We've done that a lot. And then geometric, the sum is your first term times 1 minus the ratio, common ratio raised to the n, 1 minus r. So we're going to use those depending on what's going on. So 1.50, 1.45, 1.4, 1.35. So D here is negative 0.05. Small d, it's increasing, and then 20 is how many numbers we have. So if we plug this in, we have 20 over 2, and we have our first term 1.50, but we don't have our last term, and that's what we need to find. So I'm going to write an nth term equation real quick so that we can just plug in 20 rather than have to subtract 0.05 a bunch of times. Or you could just say 1.50 plus 19 common differences will give us our 20th term, and that's what we want to find. So if we subtract 0.05 19 times, you get 0.55. And so that is what goes into our sum. And we get 10 times 1.50 plus . So if you add up all these numbers, you're going to get 20.5. All right. So in this next one, we've got negative 15, then a negative 7. So we added 8. We added 8 again. So we have another arithmetic. But I don't know what number 521 is. How many numbers is 521? So if I write my nth term, it might be easiest. Nth term equation, find the term before that. It's negative 23 plus 8 times whatever n is. So 521 is negative 23 plus how many 8s? So 521 plus 23 divided by 8 is 68. That means we added 8 67 times to get to 521. You're welcome to figure it out that way as well. So the sum is 68 divided by 2, and our first term, negative 15, plus our last term, 521. First and last, number of pairs. 17,204. So that's the sum.